Why do certain derivatives not exist? In this video, we are going to cover why functions are not differentiable at discontinuities, including jump discontinuities, infinite discontinuities, and removable discontinuities. We are also going to cover differentiability at corners, cusps, vertical tangents, and oscillatory functions. This video was a viewer-inspired video. If you want me to go over a concept of your choice, subscribe and let me know down in the comments. For functions that are discontinuous at a point, there are three possible cases: removable discontinuities, jump discontinuities, and infinite discontinuities. According to the definition of a derivative, the derivative of the function of c is equal to the limit as h approaches 0 of f of c plus h minus f of c, all divided by h. For a discontinuity, if we don't know what c is, there's no way for us to solve the numerator, which includes c in two parts, f of c plus h and minus f of c. For a more general rule, a function can be continuous and not differentiable at a point, but a function can never be differentiable and not continuous at a point. Differentiation is also not possible at sharp corners or cusps. The absolute value of x is an example of a sharp corner, and x to the 2/3 is an example of a cusp. Going back to our derivative equation, the limit as h approaches 0 of f of c plus h minus f of c, all divided by h. For this equation to exist, both the left and right limit must be equal. This is because we need to have only one single defined slope. We can't have the function approaching multiple values because we wouldn't know what slope to choose for that value. A function is also not differentiable at a vertical tangent. For example, x to the 1/3 is an example of a vertical tangent. A derivative represents a rate of change, or slope. A vertical tangent has an undefined slope as we approach the vertical line. As you can see in the graph, a vertical line is basically a change in y without a change in x. Y is changing, but x is essentially equal to 0. Dividing by 0 is bad, and it is not allowed in math. Another place where a function is not differentiable is for oscillatory behavior. An example of this is x times sine of 1 divided by x. As you can see in the graph, as x approaches a point that's not differentiable, the function oscillates infinitely in a small neighborhood. Thus, there's no way to know the slope because as you approach, there's no defined value. Thus, there's nothing to plug into the derivative formula of the derivative of f of c is equal to the limit as h approaches c of f of c plus h minus f of c divided by h. In summary, for a function to be differentiable at x equals c, the function must be continuous at x equals c. The slope must approach the same value from the left and the right. The slope also cannot become infinite. Finally, f of x cannot oscillate infinitely at x equals c.